right, these are our notes on transforming parent functions, and you can start by doing the warm-up yourself, pausing the video, coming back, and seeing how you did. All right, so here is my answers. I was like, where did those dots go? There we go. They were on the vertices. So check to see how you did, and let's move on to today's notes. All right, so in this first part of today's notes, there are some graphs that you need to know. There are 6 of them. I had to count real quick. There's 6 graphs that you need to know, okay? So if you look at the directions here, it says use Desmos on your graphing calculator or graph using points, whatever, it's up to you. And these are our main default equations, and we'll be applying transformations to them, and you need to know what these look like. So go ahead, take a moment, do those 6 graphs, make sure you know what they look like, and then you can compare them with mine, and I'll tell you some key points that you should know. Okay, so these are our 6 graphs. The first one is a linear equation, okay? So that is in the form of a line, y-intercept of 0, 0, slope of 1, right? And you need to know that that's linear. So all of these names you should know also, okay? All right, so y equals, or f of x equals, the absolute value of x is an absolute value function, and then you need to know what it looks like, obviously, but you also need to know at least 3 key points, so negative 1, 1, 0, 0, and 1, 1. Next one, y equals x squared is a quadratic. Once again, knowing the shape that it is parabolic shaped, and then the 3 key points. They're the same as the absolute value, but absolute value is V-shaped and quadratic is U-shaped. Next, we have square root function. So knowing that that's the square root function, what it looks like, and then at least 3 key points, 0, 0, 1, 1, and 4, 2. Our cubic function, we say that cubic, okay? This is what it's shaped like, and then it has 3 key points, 0, 0, 1, 1, and negative 1, negative 1. And then our cube root function, which if you zoom in, it like, oh, that could be square root, but it's not if you look at this last point right here. And it is our cube root function. So key points 0, 0, 1, 1, negative 1, negative 1, and what it's shaped like. So make sure you're not just memorizing the 3 points, because if you look, it's these 3 points, and you have to know the difference between cubic and cube root, the shape that is. All right, so what we're gonna do here in these, this lesson here is let's follow the directions and do what it says, okay? It says write what transformations would occur to the parent function, state the rule for each, and then use the transformation to draw each graph. So I'm gonna end up using the rule to draw the graph because that's what I like to do. Okay, so looking at this graph right here, this is a quadratic. So I'm gonna start actually by graphing the parent, and I'm gonna do a dashed line to graph the parent, or you could just choose 2 different colors. I'm gonna use a dashed line to graph the parent. So quadratic, these are my key points right here. If you wanna get more specific and do more than the 3 points you can. And then here's the parent. Now we use this to transform it, so it's actually very helpful to have the parent there. All right, now let's say what's happening to this graph. So if you look, we have 2 transformations happening. It is being moved right to, so we're gonna say shift right to. And it is moving down 1, so we're gonna say shift or translate, either one. Down 1, okay? So now writing a rule for this, xy becomes, for my x value, I'm gonna add 2 to it since it's moving right to, and then for my y value, I'm gonna subtract 1 from that. Okay, so there's my rule, and now I'm gonna graph my new function. All right, so all of my points I'm moving right to, down 1. And if there's no stretching or compressing or reflecting, that I just do what it says to all of my points. So if I move 0, 0, right to, down 1, it's right here, and then I have these points right here, and then I can make my upward facing parabola. And there she goes. All right, let's look at the next one here. The next one, I have a square root function, okay? So I'm gonna start off by drawing the parent, 0, 0, 1, 1, 4, 2. Those are the points I have memorized. Then I'm gonna use a dashed line to graph it, okay? All right, now I'm gonna say the transformations that are happening. Remember to make sure you're going in the correct order. Start with the h value there. That's being moved left 2. So I'm gonna say shift left 2. Sorry, yeah, left 3, my bad. I can read, I swear. Shift left 3. There is a b value of 1, so I don't have to worry about that. And then the a value is 2, so I have to address that now. So for my a value of 2, we are going to say in words that that's on the outside, so it's vertical. And then stretch by a factor of 3. Or sorry, by a factor of 2. By 2. Okay? Also, as a reminder, what that means, you're going to do 2 times y. So you're going to double your y value. Okay? All right, so we are going to shift. Let's write our rule. Let's do that. Let's write our rule because that's what I'm going to use. So we're going to shift left 3, so that's x minus 3. And then we are going to double our y value, 2y. So I guess I wrote that twice, which is extremely unnecessary. So, okay. All right, so let's go ahead and do that to each of our points. So 0, 0. So you could plug 0 in here, plug 0 in here. You can look at it however you want. Or it's 0, 0 being moved, so it's not going to be that difficult, right? So it's left 3, and then multiplying 0 by 2 doesn't do anything. So right there. Okay. And then our point of 1, 1, if I plug in 1 here and 1 here, that is negative 2, 2. So notice that is pulling it farther away from the x-axis. And then 4, 2, if you plug in 4, you get 1. And then if you plug in 2, you get 4. And then if you look at what you're supposed to have this vertical stretch pulling it away from the x-axis. That's what you have. Yeah? All right, let's move on to the next one here. We are going to start to say what's happening in the correct order. Nope, I'm going to start by drawing the parent function. I forget my own order that I'm going to do it. This is the absolute value, which is V-shaped. So I'm using the same values, or the same points as the parabola, but this is V-shaped and not U-shaped. Okay? All right, let's say the transformations that are happening. So starting on the inside with our horizontal shift, we have a horizontal shift right 5. B value is 1, so don't have to worry about that. We're going to move on to our A value, which there's 2 things happening with our A value. The fact that it's greater than 1, the 3 is, and then there's also a reflection. So I'm going to start with the fact that there's a 3 there. So I'm going to say vertical stretch by a factor of 3. And then there's also a vertical reflection because of that negative. And then lastly, I'll talk about the vertical shift up to. All right, so now let's write our rule. I hate that that's not in red, but it's okay. Let's write our rule. So we are shifting right 5, so that's x plus 5. And then for our y value, we are vertically stretching it by 3, right? So here's y. We're vertically stretching it by 3, so we're going to multiply by 3. We're vertically reflecting it, so we're going to take the opposite of that, and then there's a vertical shift of 2, so that we will then add 2. All right, so now I'm going to go ahead and do that. If I plug in 0, 0 into here and here, I get 5, 2. So it's moving it right 5, up 2. And then my other 2 points here, so that was at 1, 1. So if I plug in 1, I get 6. If I plug in 1 into the other one, I get negative 1. All right, and then I have this point right here also, okay? All right, so I plug in 1, I graphed it wrong. If I plug in 1, I get negative 1. I was gonna say that makes no sense. So then I have its reflection over the vertical asymptote, the axis of symmetry there. So that's why I was able to get that other point quickly. All right. All right, let's move on to the next one here. So first off, the parent function, I see that it's x squared, so that is a parabola. So same 3 points as my absolute value function. Oops, I'm gonna put it dashed. But it's U-shaped, not V-shaped. Okay. All right, now let's get our transformations here. So there is on our, if you look at our last quadratic, there is parentheses involved. So when there are no parentheses in a quadratic, that means it's just around x. So if you want to add them to make yourself feel better, you can, but you don't need to. But that also helps you see that there's nothing happening horizontally. There's no horizontal shift left or right, and the b value is 1, so we don't have to worry about anything horizontal. We do have vertical things happening, however. We have that 1/2 in front, so that is a vertical compression. By 1/2, okay, and then we also have that negative in front, so that's a vertical reflection. And then the +4 on the end is a vertical shift. I'm going to say shift. We don't have to say vertical shift because we're going to say up. So then we have that vertical shift up 4. All right, let's go ahead and write our rule here. So as a reminder, nothing is happening to x. You're just leaving the same x value. And then for your y value, we are going to compress it or multiply it by a factor of 1/2. We're going to vertically reflect it, so take the opposite of it. And then we're going to add 4 for +4 to move it up 4. All right, so let's go ahead and plug in our values here. If we plug in 0, 0, we get 0, 4. If we plug in 1, 1, we get 1, right, for the first part. And then if you plug in 1 in for y in that part of the expression, you get 3.5. So we have this point right here, right, and it's reflection, right? If you don't like that, it's that point, you can go ahead and plug in 2. Like if you're like, I don't like that, you can plug in 2, and then you get 2, right? So if you want to make sure you're doing it correctly, but like there's nothing wrong with decimals, right? There's nothing wrong with fractions. All right, moving on to the next one. The next one, we have a square root function, okay? So square root function, the parent, 0, 0, 1, 1, 4, 2. Okay, and now we're going to say the transformations that are happening. All right, so we're going to start on the inside. Now, remember, in order to see that horizontal shift, the b value has to be factored out. We learned that yesterday, and it is currently not factored out. So if I want to see the b value, if I want to physically see the b value, what we're going to have to do is factor that, we're going to have to factor that 2 out of that inside the radicand there. Sorry, I'm talking over myself here. So I have y equals negative square root of, and if I factor that 2 out, I have x plus, and then remember, factoring out is the same thing as dividing out, so it's 5/2 and then minus 6. Okay, so now I can actually see with my eyes by looking at it my horizontal shift. So we're going to say that there is a shift, right? That is left 5/2. It's not left 5. And then we also have this b value of 2 right here. So we have a horizontal, horizontal compression by a factor of, and then remember for horizontal compressions and stretches, it's the x value, it's that b value over 1, it's 1 over the b value or the reciprocal of the b value. So if I take the reciprocal of 2, it's 1/2. Or if we were looking at ordered pair or like x values on, we could also just divide it by 2. Or it's x divided by 2 or 1/2 of x, whatever that is. Okay, so horizontal compression by 1/2. We did our horizontal. Now we can work our way out to verticals. So we did HB, we're working on A. In front, I see that there is a vertical reflection. Vertical reflection. And then finally we have a vertical shift up, or sorry, down 6. All right, now I can state my rule, XY becomes, and so let's, 2 things happening here, okay? So there's 2 ways to write this. You can do, on your x value, you're going to shift left 5/2, that's minus 5/2, and then you're going to do a horizontal compression of 1/2, so that's one way, okay? If you're just looking at these words or you're looking at this. But another way of doing it, which I personally prefer, so I'm going to end up erasing this, is that I look at this, okay? And I say, all right, so if on my x value, I'm going to subtract 5, right? And then I'm going to divide by that b value, so divide by 2. If you look, these two things are equivalent, because if I divide this by 2, divide this by 2, I get the above. So I like writing it like that, personally, okay? But either one is fine. So I'm gonna do x minus 5 divided by 2, or another way of writing it is 1/2 times x minus 5. These are all equivalent, all right? And then for my y value, I have my y value. I need to reflect it and then move it down 6. Okay. Okay. So there's my rule. And then I'm going to go ahead and get my points here. So plugging in 0, 0, I get -5/2, -6. So that's -2.5, -6. Not the prettiest thing I've ever seen in my life. All right, now for the point that was at 1, 1, if I plug in 1, I get -4/2, which is -2. And then plug in 1 there, I get -7. So I get -2, -7. And then I need one more point, but I could already see what it looks like, because it's gonna like blah, right? The last one was 4, 2. So if I plug in 4, I get -1/2. And then if I plug in 2, I get -8. So it's like here, right? Okay. Doesn't fit on the graph paper, not my favorite, but it's okay. All right, next one here. Is it the last one? All right. All right, last one, we have a cube function. So the parent of a cube, 0, 0, 1, 1, -1, -1. And then it's looks like that, okay? All right, and now let's say what our transformations are. So starting on the inside there, we have a horizontal shift left 1. Working our way out, we have a vertical compression by 1/2. And then a vertical, I don't have to say vertical, I can say shift down 2. But it's a vertical shift down 2. All right, our rule. So for x, we're shifting left 1, so that's x minus 1. And then for our y value, we are compressing by 1/2 and then shifting down 2. Okay. All right, so let's go ahead and get our new points here. So 0, 0 becomes -1, -2. -1, -2, or right there, right? And then 1, 1. So plugging in 1, I get 0. Plugging in 1 there, I get -1.5. So 0, -1.5. And when I plug in -1, -1, I get -2. When you plug in -1, you get -2.5. What did I mess up on? Let's do my math here again. When I plug in 1, 1, I get 0, and I plug in 1 there, I get -1.5. I get that right. And when I plug in -1, -1, I get -2, and if I plug in -1 there, I get -2. What's my math happening right here? -1/2. I get -1/2 minus 2 is -2.5. So -1, -2. Oh, that's why. -2, 2.5. I graphed that point wrong. Oh my gosh, this whole time. Hopefully you saw that. This point right here. Let me highlight what I'm talking about. This point's graphed wrong. That's why I'm like, what's going on? Okay, let's erase that. Let's graph it in the right place. And then now this one makes sense. Holy moly. At least I figured out and didn't give up, right? All right, so there's your graph. And if you look, that looks like a vertical compression. It looks like someone took it and sat on the top and squished the bottom, right? Okay, all right, there's our notes for today. You can go ahead and get started on the homework.